Yeah, you can speak.
All right. Thank you for that, Aman. Hi, everyone. My name is Trishal, and I'm a senior consultant with Deloitte's India firm. For about 4 years now, I've been a part of the space practice within Deloitte, where we've been advising government departments and some of the companies in the newly minted space sector, per se. A large chunk of this work revolves around geospatial development and, say, the usage of satellite data products for client advisory. We use it as in our own workflows when we're building Excel sheets and models, typical consulting work. But we also build SaaS-based workflows for clients that are interested in using some of this data. But how I came across CoreStack and Professor Azadi's work was during the year or so I spent volunteering, working with another civil society organization called Agami, where I got to contribute to their AI open networks and some development initiatives. I played a very, very small part in helping them roll out a system that's now being used in a high court, piloted in a high court in the country. And that's how I was exposed to this ecosystem of Gramani and all the folks, doing good work in the field of technology for good and open source work that now that's being taken forward by CoStack. So glad to be here talking to you all. And if I can jump right into it, let me share my screen. Aman, I think you have to give me permission to share my screen and walk through the app. And while I get that permission, I must say that I've been an avid hiker all of my life for as long as I can remember. And I wanted to take it one step forward where I fused my interests in geospatial analysis and my passion for the outdoors. And when I came across the CoStack Innovation Challenge, I thought this would probably be a good opportunity to try that. And that's why I came up with the idea of, and I'm sure several of these exist on the market. I just wanted to build out one more that's more contextualized for some of the data sets that interested me. And that's how the idea of fields was born. Basically, if anyone works with geospatial data sets or global models, Dynamic World is one example, and there's several other LULZ data sets out there. We know that these are highly probabilistic models. Even if we're doing something as simple as extracting a building footprint, say even the leading data sets across the world, as amazing as the tech is, and as much as it helps our own workflows, we realize that they are prone to errors. Building footprint, for example, tends to fail in coastal areas. And similarly, anyone who's used LULC products like Dynamic World sees that sometimes you will have very vague results, like seeing snow and ice over Bangalore and Hyderabad, right? But these datasets also allow us to configure them using, say, thresholds and probabilities or confidence scores that we can assign when we're querying these datasets. And based on that, we can tweak the results and contextualize it to be more appropriate for our areas of interest, right? And that's where the idea of fields came about, where if we can start validating some of these claims and export those validations in a structured format, we can ground the probabilities and predictions using maybe like a RAG-based framework. But in a best case scenario, even fine tune some of these models wherever possible in making the right predictions when we are generating map layers. So that being said, let me just walk you through the workflow of the app. And Aman, I'm sorry, I still don't have sharing permission.
Try and allow. Share, yes, all part.
Yes.
Yeah, thank you.
Right. I hope my screen is visible.
Yeah, it is.
All right. Thank you for that. So the idea was an offline first app where, say, for any map layer that we have generated, can be vector, raster, anything of the sort, it should be pre-bundled and loaded onto the app such that we can take it onto the field and start collecting some of this ground data, right? Right now, if I just, okay, let me just, first things first, if anyone clones the Git repository and if you want to test it on your own browser, all you have to do is go to the main field of the app and just run it like you would run any other React or JavaScript app, and it's good to go. All I've done after that is open a browser and just make it seem like a mobile view. But there's also a GitHub Actions workflow setup where every time this code is updated, an APK file that's ready to run on any Android device is generated. So all you have to go do is go to the Actions tab in GitHub. If I can show that. Just a second. Right. Each time the code is updated in the main branch, you will there's an artifact generated where we can get a zip file which would contain the APK code that can install this on any application, right? But it's just for this, to make it more easily demonstrable on the call. I've brought it up on a web browser itself. So the same web app interface, I've used the Android SDK console and some free open source JavaScript APIs uh, to what do you say, create to enable easy conversion into APK files, but also some of these APIs help us with exporting the data that we've collected in zip files as a direct download, or to export it to an email or Google Drive or something like that, right? The connected APIs. Uh, right. So as of now, what's been loaded onto this app is it says 30 layers, but it can broadly be classified into administrative data, uh, into land cover maps, which include some of the forest maps, um, and urban expansion, which basically is the subset built up area within dynamic world. So when I say 30 different layers, I go back to what we spoke about in terms of confidence intervals and probabilities that we're setting when we're querying these data sets, that we get different versions of these maps and make as many of them available as possible. So we see which one is closer to the ground truth, right? What I'm showing right now is probably my favorite view of this app, because this is also a problem I was interested in, that and the idea of this came out with regards to public policy, and specifically the policy of the European deforestation regulation that's going to come into effect at the end of this year, um, where, say, producers of quite a few commodities, producers or traders of quite a few commodities, like, say, palm, cocoa, rubber, cattle, uh, etc., have to prove that the plantations from where these produce were harvested didn't actively contribute to deforestation since 2021. And for anyone who's familiar with some of these crops like coffee, know that it's grown in shade, which means how do we really differentiate between which of these are commercial plantations versus which of these are forests? And because for a satellite image, both of these would ideally look like the same, right? Um, and so the idea was, if we can leverage, say, time series data to look at, say, the growth cycles of these trees and then differentiate and see which of these trees have been there for 5 to 10 years versus which of them have grown in, say, the period of our analysis. And typically, SAR data allows us to do this kind of analysis. But thankfully, for the case of this app, this is work that was already done by Google and put out as the National Forest Dataset of 2020, where again, based on, say, some confidence intervals that we set, we can get different views of what its predictions of old growth forests are. And that's what we're seeing here. If I show you what maps layers are enabled right now, it's this old growth forest layer with, if I'm not wrong, I think it was a confidence interval of about 61%. And when I say plantations here, it's the query of dynamic world for tree cover minus the layer for old growth forest that we have predicted. And that's what we see in light green over here. So the idea was to say take this onto my year-end hike, and then as we walk past some of these hills, and fortunately, the region that we had picked, or unfortunately, the region we had picked had a lot of commercial plantations that had come up in what was classified as reserve forest, right? So we're going through a forest office, but you can see that a plantation is there and people are harvesting coffee. The trek specifically was Bandaje Falls, where we start in Chikmagalur and we end up in Dakshin Kannada. And where a plantation ends and where a forest starts, except for the fences that have been put up, it's harder to demarcate. Um, Nevertheless, so what the workflow per se of the app is quite simple. That once these layers are loaded, and if you're on a phone, you will see your GPS coordinates wherever you are. All the user has to do is capture a photograph. And once that's done, when it's updated in the logs, if I can show you how those logs are exported later, um, in the logs, the latitude and longitude of that photo allows for querying of all these layers that have been made available offline. So whatever data is there offline, we are tagging to that photo for that specific location, right? But also, when there is an online mode, it queries two services. One is the CoStack APIs for administrative data, and the second is dynamic world again for if because there's a data set that updates every 5 days based on the latest available Sentinel imagery. We want that latest data tagged to that location as well. And the third one is, of course, weather data that was for that appropriate time when that photo was captured. The weather data for that time is pinged and tagged to that photograph there. And once all of that's done, as a zip file or using the connector API for Google Drive, the logs can be exported as a CSV or as a GeoJSON, which means that you can directly put it on your QGIS or your own custom map interface, like or Google Earth. And actually, I'm sorry, Google Earth only supports KML for now, but okay, note to self, I should add a KML export feature too. But yeah, so we're minimizing the workload between, say, field observations to, say, a geospatial scientist opening up the data and quickly refining how they do their analysis, right? So that's on the broad workflow. In terms of, if I were to show a demo of, say, how we're, say, querying CoStack data, let me see. I think the last district that I tested this for was in Maharashtra. Let me try that. Oh, sorry. Yeah. Let's see. Maybe there's some. Wait, I think the Manrega points came up quite well, and right. Now, this is naturally because I'm running it on a system that's connected to the internet. It can load like this. But there's also an option to preload this data as we're bundling while we're pre-bundling the package, and this can be made available, and people can go to these sites and attach their own photographs and notes of these regions. And even if that's not the case, if say they have offline access, like in a document of where these sites are, and even if it's not showing up on their app, if they go to the site, collect that photograph, if and when the app comes online, then this data can be tagged to it appropriately as and when connectivity is made available, right? So I guess in the worst case scenario, when we can't even use this data for model training, when we can't use it for grounding our predictions, it's at least a fancy app where we're taking relevant notes from the field and at least export it in a structured manner such that we can use LLMs and all of our other tools that we can use when we're online and do some analysis on it. Right now, there's just some placeholders that I'm calling guides over there that where based on the specific types of field work that we want to do, we can provide these guides in native languages to the folks who are going to be using them. But like I said, this is primarily placeholder for now. And finally, and I think this is in relation to some of the queries that Dr. Adi already asked on email. How do we take this beyond, say, a static app that is giving you pre-bundled layers, and how can we, put it into production per se, such that organizations can actively start using this for their field efforts? As you can see right now, there is no authentication flow to this, right? If before installing the API package, within the settings, there's the option to configure your CoStack API key and your Google Earth Engine API key for using Dynamic World. Now, ideally, this isn't bottleneck anyone who has to use this app on the field should be using. So for that, probably authentication, user ID, and rate limiting flows has to be built into this app. Secondly, on configurability of these layers, right? Right now, I as a dev have to go and manually add these layers that is then being packaged, and then I have to create a manifest in the form of a JSON that's pointing the app to where these layers are within that package. Again, that is a bottleneck I'd like to do away with. Now, this is some work I have done in a professional capacity with Deloitte, but I haven't really done it for this app yet. where we have allowed users to work with any form of data that they have from their fields. It can be something as simple as engineering drawings, Excel files with coordinates attached to it. And if that is uploaded, how can we serve it on the map and allow them to quickly do some kinds of analysis? Uh, it can be anywhere from, say, tracking environmental parameters around there to, say, water quality, or again, land cover and how that's changed recently or over time is something that we can do. So that ETL pipeline per se is also something that I'd like to work on. And finally, of course, the real utility of this app would be in trying to bring together more and more data sets. Right now, I'm using GLC FCS 30D. That's a Landsat-based land cover mapping service. Land cover classification dataset that's available on the GE community catalog. I'm using this dataset for land cover mapping from 1987 up until 2018, from when we have dynamic world data. Because that is Landsat data and that is available at 30 meters only, even the dynamic world data had to be reprojected or refactored to 30 meters instead of 10 meters, which is just so the overlap does not mismatch. And thirdly, where we're getting CoreStack for administrative information right now, as in I'd like to have the equivalent of an MCP in current AI parlance, where we're constantly tracking what new data sets is available through the CoreStack APIs, and as and when that's available, dynamically fetch that into the application, such that if we click on any point on the app right now, you can see that it's loading whatever CoreStack watershed information, or at the very least the administrative boundaries, which taluk that belongs to, etc., and the weather data. I haven't put the GE key yet, so you don't have the dynamic world data coming on tap, but it will happen for photographs, right? But yeah, so this is currently giving you an overview of all the data sets per se that's available through the CoreStack APIs, but to extract from the data sets and give only the meaningful information to the user is what I see as the next step for this. Something as simple and intuitive as weather, right? When we click on weather analysis for any given region, it's processing a lot of complex data from different sources, but giving it in an intuitive way for us to understand it. And ideally, that's the route I would like to take with, say, CoreStack or any other trusted geospatial data sets that's out there. So yeah, I spoke nonstop for 20 minutes now. I think that's my demo of the app. I'm happy to answer any questions or queries or suggestions for what I can take up for next steps through this.
So Amit here have some question.
Okay. So I just wanted to ask, the last layer you were showing, and wonderful work for like, yeah, to integrate all these different kinds of layer. But yeah, so in this layer, these are all data points that you have where you gather the ground truth data, right?
No, I'm sorry, I didn't catch. I think Amit.
Okay, so these okay. So another question is basically based on how many like ground truth data you have collected so far, and did you find like um different kinds of layer would be we would be able to supplant different kinds of information uh, to manually to automatically categorize these layers into different forms. And was there anything that you found that these layers are good in this kind of for this kind of categorization? These layers have this categorization very well showing very well categorization for fields, and some other a layer is showing it. These all things we can infer from this, right? We would be because you are taking in so many layers at one point at the same time. So I think it could be very helpful for cross validation and overall comparative analysis of different kinds of layer. And also, how are you loading these layers? So many layers at the same time. How much are the server costs or those things? Are you directly loading rasters or?
I am, yes. So I think there was three parts to that question,
Okay.
right? So first thing, what we're seeing right now on screen are the base layers itself, right? This isn't what I have collected on the field, etc.
Yeah.
That's only available on my phone right now, and I haven't really exported that anywhere beyond the Git repository of the source code, right? It's not more than 12 data points, if I'm not wrong, that I've collected, and it was specifically on the old growth forest data set, right? Because, but the in my head, the original idea beyond that for that collection is just to look at how can we structure the data that's being collected there rather than how many data points can we go out and collect there right now, right? Because that is the eventual idea. But I first wanted to see, what's the most efficient way of collecting the data, structuring it, and exporting that data. Uh, so that's on the first question of the view that I showed over here. What we're seeing here as purple points are the CoStack API call for Narega sites for the region that's on my screen right now. This would be Pune, which was the region in Western Ghats that I found most applicable for this. Also, because I was the region of the Western Ghats that's apparently undergone the most amount of deforestation in the last 20 years. Which brings me to my second question on, say, the which data set fared better than the other. Like I mentioned, there was two different data sets that I used for land cover classification, right? The first was GLC FCS 30D. There's more details of this on the repo. And the second was Dynamic World. In both cases, there was different versions of those layers, right? If I can go back to that. See, in natural forest, what I've chosen here as old growth forest was a 60% confidence that I had set. There was also 52% and 80%. And these were randomly picked up numbers, right? To
These
try and see which
confidence
one.
numbers are based on like 12 data points, right?
I'm sorry, what data points? I didn't hear that.
Ground truth data points, your confidence level. Can you define confidence level?
So when we are making a query for any given point on the natural forest dataset of Google, we're supposed to give, say, a confidence score for its classification, right?
Okay, right.
Like saying that the equivalent of it in dynamic world against the 9 land classes that are available there, we have to manually go and give a probability threshold for it. Because if we assume the default ones, it's probably going to give you a North America like analysis in tropical countries like India. You'll find snow and ice and stuff like that coming up in South India, which doesn't make sense. So how I selected those numbers was, to be honest, completely random, right? I just wanted to create 3, 4 different layers and then go out and see, of these random layers, which ones end up performing better, such that we can generate more layers which are probably closer to the ground truth than otherwise. So as of now, what's on that screen have been randomly, I won't even say sampled, they've been randomly generated such that we can go out there and figure out which is the one that would probably perform best. And in my limited experience of this one region of Chikmagalur and Dakshina Kannada, it was a 60% confidence interval of the old growth forest set. And so that's what we're seeing as dark green over here, right? That's from the natural forest dataset. And the light green one is dynamic world, which again, I had gone and manually put these numbers based on, say, previous experience of running dynamic world queries over these regions. It was completely arbitrary and unstructured to answer your question so far. But the idea of using this is to make that a little bit more structured. Um, Finally, on say people bringing their own data into this and say how can we yes, these are pre-built raster layers that I generated using TI tiles on my laptop. And then as we're making that APK package for Android, these layers go as TIFFs or as GeoJSONs, whatever is easiest. And that can be that's loaded on the app as static files right now. But the idea that I want to enhance that with is to remove that laptop dependency and say on your phone itself, if you can upload best case scenario a GeoJSON or GeoTIFF or a shapefile, but if not that, a CSV file or an Excel file with some amount of coordinates at least, such that if not boundaries and shapes, at least points we should be able to recognize on the map. That shouldn't take too long. I can probably build that out in a week or so.
Thanks. Yeah, Aman, do you have any questions?
Yeah, this is good, really wonderful. So we'll go through it, right? And we'll connect over emails, right?
Yeah. Like I mentioned, I mean, it's a very early prototype, so please, as many thoughts as you and your team have, I'd be happy to
Sure.
explore it with you guys. Yeah.
Yeah, even if you don't provide the authentication and all those things permanently, I think this can be itself be open source, and anyone who has who can request code stack or some other API keys from different people, or GE or WRI or other people, they can use their API and to go to different places and verify their layers on their behalf. And I think it this may be really wonderful and we can encourage people to actually get digital world to know your physical space actually, so that you actually get better information and to help map your own world. Um, yeah.
Yeah. Thank you for that. That absolutely makes sense. I was thinking of it as a companion web portal for this app, where say you can go upload your own data, or you can say fetch the data from the relevant APIs and generate these layers as a field pack per se, and install it on the app before we go offline.
Yeah, like
Yeah.
ways that traffic gap, like which people build themselves.
Right. Yes.
Yeah, thanks.
Thank you.
So anyone else has any questions?
Anyone else has any idea, any suggestions for this Trishal's application, or any other questions that you may have? Or any progress you want to share regarding the innovation challenge?
Yeah, hi, Trishal. Yeah.
Right.
Am I audible?
Yeah.
Yeah. So I wanted to ask, what was your journey through making the app offline, like making all the layers available offline? Like we have done similar work in our application, like Commons Connect. Have you seen Commons Connect?
I'm sorry, Ankit, I missed quite a few of these dev calls, but I'd love to check it out if you can link me to the repo.
Yeah, sure. So it's available on the Play Store. Uh, it uses all the core stack layers, and it is available offline and online as well. So I wanted to ask, what was your journey on making all the layers available on offline?
Uh, okay, thank you for that, Ankit. So two steps in that, right? One is where we have, say, geospatial data sets that are ready to be queried and served on the app, right?
Mm-hmm.
In these scenarios, it was pretty easy to generate the raster tiles using tiler, and say we end up making a COG, the cloud optimized geotiffs,
Mm-hmm.
and serve it either as a GeoJSON or a geotiff, whatever is easiest on the app, right? So this was the easy part. The second is where we have, say, unstructured data. And this is particularly something that I dealt with when, say, just trying to pull administrative data before core stack, right? Before core stack allowed you to, say, get that through a geo server.
Mm-hmm.
In which case, we typically used a GDAL for that conversion, and then serving it as tiles, right? Uh,
Yeah.
but that doesn't give too much flexibility. And you probably know this better than I do. But nevertheless, for to have a little bit more configurability and not use a black box approach like GDAL. I wouldn't say black box. It just means that I have lesser options to working with different types of data sets, right? When we're pulling, say, really heavy weather data that can go into, say, TBs that I'm pulling directly from an S3 bucket, in my experience, GDAL is probably not the fastest way of doing that. So there was another exciting open source project for that. This was called XPublish Tiles. This was made by Earthmover. Anyway, it's a completely open source package which allowed for the creation of vector data tiles from really heavy data sets, and it ends up using the XPublish library to serve it as map tiles, which makes it much easier. So yeah, to answer your question, it was a combination of GDAL, GeoServer, TI tiles, and XPublish tiles.
XPublish tiles. Yeah, okay. Nice. Thanks. I'll
Okay.
look up.
Yeah, and I'd love to check out your application too. Yeah.
Yeah, Aman has shared the link, I guess.
Okay. Okay. Awesome.
Okay. We can call it a day then. Thank you. Thanks a lot, Trishal, for sharing all your work. Yeah.
Thank you for having me, and I look forward to speaking again.
So, okay, then see you guys next week, same time. Bye bye. Thank you.
Thank you.